Hello everyone. Let's go through the new protection functionalities for our generic distributed energy resource, or DER components, VoltVAR, Herz Watt, and VoltWatt. We'll go through these new protective functions using our battery inverter generic component. You can find an example of this, the battery inverter component, in our Examples Explorer menu. As you probably know, the main motivation for this new generic component is that compared to our legacy components, it provides an easier and more practical parameterization from the system integration point of view. Also, it includes new functionalities that you will find in many real-life applications such as protection, frequency drift, and phase check. Finally, it doesn't utilize the machine solver of the Hill hardware, which can help you to create bigger models with a larger number of generators. To find the battery inverter generic component, go to the Microgrid, Distributed Energy Resources folder in the Library Explorer. As you can see, the generic system has two parts, the generic UI, which is used for interfacing between the generic components and the I/O, and the generic component itself. The generic component part is implemented using signal processing and signal-controlled voltage sources. The mathematical model is implemented using signal processing. There is a possibility to change some basic parameters. The model also consists of a grid and a constant impedance load. From the 2021.2 version of the software, the VoltVAR, Herz Watt, and VoltWatt protective functions will be included in all inverter-based DER generic components. You can parameterize the VoltVAR, Herz Watt, and VoltWatt protective functions in the Grid Codes tab on the mask of the generic component. The main functionality of the VoltVAR function is to keep the battery connected and injecting reactive power over a predefined grid code. The Herz Watt and VoltWatt functions do the same, except by injecting active power as a function of frequency and voltage, respectively. With the 2021.2 release, VoltVAR, Herz Watt, and VoltWatt functionalities can be defined by custom requirements. The battery inverter generic example has its own SCADA panel. In this SCADA panel, we can see that we have a grid interface group where we can find basic measurements. This SCADA panel is slightly modified for the VoltVAR, Herz Watt, and VoltWatt test purposes. In the battery ESS interface subpanel, we can see that we have an inverter control and status group where you can find basic control parameters. To start the inverter, you have to check the Enable checkbox. The inverter will then start to work in operation mode, which can be parameterized in real time through the grid interface panel. To enable grid codes, the DER, in this case the battery, has to be in grid following operation mode. We have added VoltVAR test, Herz Watt test, and VoltWatt test buttons to the automated test definition. To active VoltVAR, Herz Watt, or VoltWatt, just check the appropriate checkbox in the grid codes panel. You can have multiple functions enabled at once. If grid functionalities VoltVAR, Herz Watt, and VoltWatt are enabled, then these curves have priority over the LVRT active and reactive power contribution settings. It is important to say that VoltVAR, Herz Watt, and VoltWatt protective functions will work only in grid following, so let's see what happens when we set that mode. Currently, we can see that we are in a steady state without operating in grid following mode. Let's run the VoltVAR, Herz Watt, and VoltWatt test. Now I will show you the VoltVAR test. Here we can see that we injected a reactive power to the system. Let's return the voltage to 100% normal conditions. Now I will show you the Herz Watt test. Here we can see that we injected active power to the system. Let's return the voltage to 100% normal conditions. Now I will show you the VoltWatt test. Here we can see that we injected active power to the system. Let's return the voltage to 100% normal conditions. To summarize, in this video, we presented new grid codes for microgrid generic component. Also, we saw how to use it and where to find the example model for it. We also saw how to use the SCADA subpanel for this component and how to control it.